In this video, I'm going to prove that the derivative of arcsin of x minus 1 over x plus 1 is equal to the derivative of 2 times arctangent of the square root of x and then minus pi over 2. Okay, so first let's start with taking the derivative of this. First of all, I'm going to say sine inverse of 1 is going to be equal to 1 over the square root of 1 minus x squared. If you don't already know that, you should learn that, I guess. And then the inverse of tan is equal to 1 over x plus 1. If you look at all the 6 trigonometric identities, they're going to have a nice little pattern to them. So I advise you to go check that out. Okay, so let's go plug this in. So we're going to have 1 over the square root of 1 minus x minus 1 over x plus 1 squared, and then we're going to use a chain rule. So it's going to be, now we're going to use the quotient rule, so it's going to be the derivative of this, which is equal to 1 times x plus 1 minus 1 times the derivative of that, which is 1 times x minus 1 over x plus 1 squared. That is going to be equal to, we can just take this 2, put it over here. Or sorry, I messed up when I wrote this. That is a very silly mistake. As you'll notice, all the 6 ones have a squared for the x. The cos, like cosine, cosecant, cotangent, they have a negative before it. And I believe like secant is 1 over x square root 1 minus x squared, but don't take me to court with that one. So it's 1 over 1 plus the square root of x squared, which is x, plus 1 times, and then we're going to use the chain rule here. It's going to be 1 over 2 square root x, because x to 1/2 prime, that's 1/2 x to negative 1/2, which is that right there. And then the negative pi over 2 just goes to 0. So I can simplify this a little bit. I can cancel out these 2's. And so the number I'm trying to reach on the left side is square root of x times x plus 1, okay? Now what I'm going to do is I'm going to try and do something with this part right over here. I'm going to write this 1 in terms of x plus 1. So it's going to be 1 over the square root of x plus 1 over x plus 1. And now, since we want it to be under the common denominator, I'm just going to square these both. And then it's going to be minus x minus 1 squared. So now, like unlike previously when we just had this 1 here that we couldn't do anything with, now we have it on a common denominator and we might be able to do something with that. So you'll notice that I can take this out, and so it would be 1 over x plus 1, because this and the square root cancel, times the square root of x plus 1 squared minus x minus 1 squared. And now if you evaluate this, first we can put this x plus 1 on the top. And this right here, let's evaluate this. This will be x squared plus 2x plus 1 minus x squared minus 2x plus 1. When we distribute, we'll see that it equals 4x. Okay, and I'm just going to take that 4 out, and because the square root of 4 is 2, so I can just take that out right there. Now we've evaluated this part, so let me write it with this down here. It's going to be x plus 1 over 2 square root x times, we can just forget about this one for now, x plus 1 minus x minus 1 over x plus 1 squared. And now we want that to be equal to 1 over the square root of x times x plus 1. So let's go ahead and evaluate this. X plus 1 minus x minus 1. Well, this negative is going to go here, so these two x's are going to cancel out. This negative is going to turn that negative one to a positive 1. 1 plus 1 is 2, so this is going to be 2 over 1 plus x plus 1 squared times x plus 1 over 2 squared of x. You can see how nicely this all cancels. You can get rid of the square over here. It's equal to 1 over the square root of x times x plus 1. Oh, is that what we had up here? Yes, it is. We have just shown that these two are equal. Wow, that was a lot of algebra over there, but thank you very much for watching, and goodbye.